To the rehabilitation design of Farrelly Highway in Victoria. Just a little bit of background. The highway has 4 lanes, 2 lanes in each direction, so there's east and west direction. The total length of the section we're considering is 3.5 meter, and the lane width is 3.5 meter. The seal shoulder width is 1 meter. There's seal shoulder width on inner lane and outer lane. The original design traffic was 2 multiplied by 10 to the power 6 equivalent standard axle. The new design proposed was same for the inner lane, but for the outer lane it has been doubled. The parameter that we measured was deflection, curvature, and roughness. Upon investigation of the pavement, the following thickness of materials was found. The wearing course is 50 mil AC10, and there's a leveling course of 75 mil of AC14. The granular base course was 20 mil rock. Sub-base was 40 mil crushed rock, and the subgrade was severe was found 7%, which is better. The standard practice is 4 to 5%, so which is good. The deflection data for the westbound inner lane was you can see there's inner wheel path and outer wheel path, and the roughness is on the top, and this is the outer wheel and this is the inner wheel. You can see it's pretty much straight until it reaches around 3000, where it suddenly goes up. And for the roughness, you can see suddenly there's a big change around 1000, and it goes on and around 3000. So you can see there's quite a big variation in terms of the ride quality. For the outer lane, so this is the outer lane, and this is the inner wheel path, and this is the roughness, and you can see it's almost as homogeneous until it reaches around 3000, where it picks up and the deflection goes off. And in terms of the roughness, it's also the same scenario here as before. Around 1000, there's a sudden spike in roughness, and around 3000 is also the same. So the ride quality is similar to inner lane. So we've done a few deflection data analysis based. The section has been divided into 5 lots. So each lot is homogeneous in terms of material quality, behavior. So the mean deflection for lot 1 is, say for example, is 0.51, and the characteristics deflection is 0.71, and design deflection based on the traffic is 1.09. So you can see if design deflection is higher and characteristics deflection is lower, so we don't need any overlay, and it's almost the same until you come to the lot 3 and lot 5, and there's some overlay required. We'll go to curvature analysis. So the curvature is something that is measured roughly from the point where the maximum deflection, which is around 200 mil or 400, 600 or 900, it depends. So the curvature is 0.16. Based on this curvature and this figure 6.6 from Auster's Pavement Guide part 5, we can see based on this curvature data and the minimum overlay, it can carry 1.2 multiplied by 10 to the power 7 equivalent standard axles, which is higher than the design requirement for both. So you can see these are pretty much way higher than the design, so they can safely take on any traffic that is proposed. If we use on top of the conventional binder, which is all these are, A15E binder, which is stiffer than the conventional binder 2.5 times. So these figures go so actual thickness we can see safely from here. So the minimum is 40 mil, but when we have 40 mil, it's already more than the design. So the minimum we need is 40 mil. So that's why the 40 mil overlay with A15E has been recommended. So coming down to the rehabilitation option 1, we're proposing unbound granular with asphalt. The proposal is the option is 40 mil heavy patch 135 and granular material. So granular material is 375, so which is around about here, and also the asphalt is 175, which is around about here. So if we go from here to here, so this comes down to this point, so which is between these two traffic load. This satisfies both the minimum requirement of this figure and also the upward figure of 4 multiplied by 10 to the power 6 equivalent standard axle. This is the cost for the next 20 years if we choose that option, so which comes down to 174, around $175 per square meter. The option 2 is using a cemented material, a bound material with an asphalt. It's been proposed 50 mil of wearing course and a thickness of 450 mil. So if we go to 450 is here and 50 mil is here, so it's the point is here, so which is way more than the minimum requirement of 10 to the power 6, this curve. So this option actually satisfies and it can take higher traffic than what has been proposed. And when we did the analysis for the next 20 years, it's found to be cheaper than previous options. So this is $123 per square meter. You can see 2 options are here. So option 2 is preferable. So preferred pavement configuration is 50 for 50 mil subgrade. The floor is open for any questions. You can ask me any questions. Thank you. Thanks for being here.